So this is question 8. Oh, I've zoomed right out there. Let's zoom. Okay. So if you've got it, you can by all means play along with us. But question 8, my hint to you was just do something. And you think, well, that wasn't very helpful. But we know it's the cosine rule. Okay, and we remember from last lesson that your cosine rule is a squared equals b squared plus c squared minus 2bc cos a. This is a formula that is provided to you on a formula sheet, but if you keep using it over and over again, you can see it just, you don't even need to look it up. Okay, recording. So learn to love it. And what was the thing that you had to remember about using the cosine rule? Something minor. Yep. I was going to say you could speak into it.
Cosine? No, I don't know.
So pretty basic. It was, and you guys probably just do it automatically, but it's that it has to be the two lengths, and then the angle has to be in the middle of those two lengths. Okay, and of course we can also use it when we're finding an unknown angle, and we would need to have all three lengths. So it's one of two problems. So when we come to do this question, a lot of us and students in the past, they see the x squared and they want to start, don't write this down, they want to start by saying x squared equals. Now, we don't want to do that, okay? Why? That's because we don't have its opposite angle. So don't start with that. I mean, and you could have started and then you got stuck. So then stop and try something else. And then we go, oh, okay, we've got this angle here. So that means we're going to start with, just pop it in the formula, right? So we go 7 squared equals x squared plus 6 squared, because those are the lengths surrounding the angle, right? Again, you're not really sure what's going on, but you're doing something. Who at least got that line? Well done, well done, well done. Okay, and again you think, well, there's no way that this looks like this, but don't give up. You need to go until you're absolutely exhausted, everything that you can do. And I would argue that you're not exhausted yet, because you at least know that 7 squared is 49. Can't do much with the x squared. 6 squared is 36. Now 2 6s are 12x. And when you put cos 60 into your calculator, it will tell you that it's a half. And so now all of a sudden, things are starting to look a little bit better, aren't they? This is starting to look a little bit like what we've got up here. So I'm just going to get and keep going. Some of you might have stopped. You saw the cos 60, there's no cos up the top, and you stopped. Always just try that next step. Does that make sense, everybody? So now we put everything on one side. We've got x squared. 12x times 6 is minus 6x, right? So you've got 12 times a half. Welcome. Okay. And now we put everything on one side. The 49 comes over. What do we think 36 take 49 is? Boo, boo, boo. Lo and behold, it is 13. Huzzah, huzzah. Are we happy with that? Okay, and if we're thinking about the hence, find the exact value of x, it might have been a while since we solved quadratics. So let's grab our calculator. Okay, so to solve a quadratic on your calculator, who remembers where do we go? Who doesn't know where you go? Okay, good. Thank you. I just, when you're looking at me blankly and you're silent, then I go, am I just boring them to tears? Or do they actually forget? So, well done. We go down to equation, right? So use your arrow keys, okay? Press your execute button, enter, then, not simultaneous, polynomial. Excellent. It's coming back to you now. So to access polynomial, we're going to press the F2. So we do that, and it's a degree 2, and we pop in, and I've forgotten what it was, So 1 minus 6 minus 13. Okay? 1 minus 6 minus 13. And by the way, why did I go straight to this and not try and factorize? Why didn't I try and factorize this thing here? Yeah, because I'm looking at the 13. The only factors of 13 are 1 and 13, and I don't think I can mush them to make 6, so forget that. You could have used the quad formula if you wanted to, but geez, let's just save our brain a little bit. Now, exact solution, exact, that means we're looking at this value here. Okay? You can see I've got 2 exact values. Can I put them both down? So we had a yes, then a wait, then a no. Don't play cricket. Yes, no, wait, run out. So if we go back, let's have a look at what are we actually solving for? We're solving for x, and what is x? A length. So can we have a negative value? No. So that's when we're just going to write down our positive answer. Is that making sense? Okay, so 3 plus, so therefore x equals 3 plus root 22 centimetres. How'd we go? Okay with that? I've lost my little pause button. Don't know if I just paused incorrectly then, but anyway, that's the answer. Hope that worked. Oh, as you just finish off the last bit. So when we talked about the cosine rule, we talked about the good old friends with the 2 lengths, the angle in the middle. When we are dealing with the sine rule, it is all about pairs. Right? We need an angle and its opposite length. You've got to have one known pair. If you don't have a pair, cactus. All right? And you're going to be able to find the length. That's why we have this formula here, because your length is upstairs. So when we're doing a question and we want to find a length, I will go to this formula. When we have a triangle and we want to find the angle, then I will be using this one. Okay? So, pairs. If we look at our first, and this is what I asked you to look at and go back over for homework, just to have a look. So hopefully this isn't going to be too big a deal for you. We look at that question, the blue triangle, and we've probably ruined the surprise saying we're doing the sine rule. But if it was just random, because that's how it's going to be in a test, it's not going to say, please use the cosine rule. Please use the sine rule. It's just going to say, find x. So you might look at it and you go, oh, could I use the cosine rule? Could I? They're shaking their heads, right? Why couldn't we use the cosine rule?
Because it doesn't have 2 lengths and an angle in the middle.
That's right. The 2 lengths and the angle in the middle. One, it's only got 1 length, so that's no good. And yeah, so no good. And we look straight away and we can see really nicely we've got a pair of known information. So we can go straight into, I'm going to do my pairs. So we've got x, and because it's a length, that's why I'm going to say x over sine of its angle. All right? So that's going to be sine 70 equals, obviously, that pair on the other side. 10 over sine 50. And we wouldn't be having fun if we didn't just have a smidgen of algebra chucked in there, just a peep, because I don't want x over sine 70. I just want x. I just want chips. No more chips for me. Cholesterol up high. Very sad. No more chip sandwiches. Is life really worth living without a chip sandwich? Enjoy it while you can in your youth. So, how do I get rid of that divide by sine 70? Times. Right, we're going to times. And you have done all the hard work. It is now all calculator from here on in. Hit that calc. normal menu. Felipe, you just want to check right at the top of your calculator, Felipe, that it's in degrees. Okay? Your neighbours will be able to help you to make sure that it is in degrees. Over sine 50. Oops. So to check, if you weren't in degrees, you would go shift setup, so shift menu, and you want to scroll all the way down, oops, to angle, and then you'll press F1. So 12.26. Before you move on, you always just do a double check. Does that sound reasonable? The other length was 10, is 12 reasonable? Absolutely. I'll confess, I was doing the solutions to your assignment the other day, and I went through, I was chatting away to the other people in the office, chat. And guess who forgot to square root the cosine rule? Yeah, me. So always just do that, saves yourself a bit of time. We good? Not actually going to do all of the orange triangle, but just wanted to check. How would you get your ratio there? Yes. Ah. So who's volunteering? Oh, Finn again. He's not shy of the microphone because he had it last year. Yep.
You add the two known angles together and then take that from 180.
Right. Excellent. So you're not just going, oh yeah, I see two lengths, I see one length, I see an angle, I'm just going to just go, oh, x over, 40 is not opposite, but it's there, I'll just go x over sine 40. Don't do that. And some of you are smirking going, I wouldn't do it. How many times have I seen it? So this angle here, I better use maybe the green, that's obviously going to be 180, take 110, take 40. So absolutely it's 30. So we will say x over its opposite angle. Do we agree? Yeah? You go silent and I'm going, oh my God, have I made a mistake? Is it 180 take 110? Is it not 30? You're freaking me out, kids. 18 over. So we don't have to finish that off. Do you agree? Calculator all day, every day. Happy? It was more about getting the correct ratio. All good? While I have you here, I'm going to remind you about the finding the angle. We're good? You okay? I'm not boring you? I feel like I am. It's all right. I'll live with that. You're going through the same process. Can I use the sine rule? Can I use the cosine rule? Which one is it? This time I do have two lengths, but I do not have this angle in the middle. So cosine rule gets the heave-ho, gets the good old flickaroony. And the fact that I have a pair, an angle and its opposite length, that's leading me down the sine rule path. Agreed? Now, right at the start, we looked at the rules, and it was two of them. It's the same rule. One is just flipped, right? Because I've got an unknown angle, that's why I'm now going to use this rule. I like to have my unknown upstairs. So we're going to say that's sine theta over, its opposite length, 90, equals sine 70 over 100. If you get that step, everything else should be okay. because again, it's simple. Ouch. Am I okay to keep going? You probably are ahead of the game here. We're going to get rid of that. Divide by 90, and we know by now that is just times. I don't want sine theta. I just want theta. We've been in this situation before. How do I get rid of the sine? Inverse it. Thank you. Excellent. So therefore theta will be the inverse of all of that. Okay, so we got 57.7 when we did this on our calculator. And we're happy to move on, but shouldn't there be a but? Who remembers when we're finding the angle, there's a big but? Okay, so there can be two possible solutions. It's called the ambiguous case. So how we talked about the area rule the other day, where the triangle can be drawn, like the arms of the triangle can open up wide. You can end up with the same measurements and whatever, but the triangle looks like a different, I don't want to say shape because it's still a triangle, but different shaped triangle. So still really technical to check. This is all we have to do. We have to go 180, take 57.7. Don't judge me because I'm using my calculator. 122.3. So what we're saying here is we're going, could the angle that we're just finding, right, so this angle here, this theta, we've got one solution that it's 57.7. Could it also be 122.3? Yay or nay? So we've got a lot of, we've got a lot of naysayers there. Can you tell me why that it's a nay?
Because 70 and 122.3 equals over
180. That's right. So check with your triangle. The other angle there is that one. Oops, the white doesn't work on white, but 70. So you cannot have, if I now go 122.3 plus 70, that becomes greater, oh, not greater than, equal to, greater than 180. So then this is my only solution. There aren't two. If I added those two together and it was less than 180, then I can have two solutions. That's it. So I did the green one. Guess what? That's going to end up being two solutions. Do you want me to go through it, or are you happy just to get stuck in? So I'd say you can get stuck in. I will just finish this on the board for those who wish to look at and listen. For those who don't and want to get going, you can dive in. Oops, that was a quick flash of people's names. Uh-oh. Let's hope that wasn't there for too long. So you should have on Daymap, on OneNote, what it is that we're actually doing and the questions I've asked you to do, but you're basically progressing, and we're going to do 6C1 and 6C2. Once again, you've got 6 questions, all finding the value of x, right? So are you going to do all 6? If you feel that you need to, by all means do so, but I would say don't. Once you finish the questions that are outlined in Daymap and on OneNote, give me a little hoy, because I made something for you. Hopefully what will happen is I will do this recording, especially if my board comes back to life, and then you can just go and have a look. If you're here in class with the videos, you really don't have to look. So Felipe, you can go and look. I think I've got 1 or 2 videos, 1 maybe. Go back and I'll show you. I have to add you to the team. Okay, so with this one, again, it's about how much of this could I actually do? And the first thing we should notice, oops, I put the pen on, is that we have pairs. Yeah? So if I said I'll give you half of my winning lottery, what could you at least do? You would say 2x take 5. And why have I put the lengths upstairs? Because that's where the x is. That's my unknown. So it's 2x take 5 all over sine 45. And then we've got x plus 3 all over sine 30. Now, apart from doing this year after year after year, I'm at an advantage of you because I know something about sine 30, sine 45, and in a couple of weeks you will know that too. So grab your calculators out, and I can tell you right now that sine 30 is a half. I can also tell you that sine 60, which is not there, but if you pop that into your calculator, it's root 3 on 2, is it not? Magic. And I haven't got a calculator in front of me. I can even tell you that sine 45 is root 2 on 2. Sine 90 is 1. Sine 180 is a 0. These are common things that we know, and we will be looking at, as I said, in a couple of weeks, and it all comes down to our sine graph. Okay? So anyway, because I know that things are going to start to cancel. So when we look at this, we've got 2x take 5. Now watch how I'm going to write this. Divided by root 2 on 2, because we know this is sine 45. Agreed? And x plus 3, you're dividing by sine 30, so you're dividing by half. Again, people who are madly copying down, you're probably better off just watching, and I will save this. I promise you I will save this in our OneNote, or I'll leave it up on the board and you can copy it then. So please, you're better off just listening. So we're now asking you to recall what happens when you divide by fraction. You can remember, how do we divide by fractions? Yeah? You replace the divide with a? Times. Reciprocal, love it. I'm a bit not as technical as you, and I just say you flip. So you flip. And obviously here, when you are dividing by half, that is the same as if you were timesing by 2. Do we agree with that? So far it's a bit of memories at the corners of my mind. I was doing this with the girls up the front here before, and now I've just looked and gone, ooh, I can even make this easier on myself, because I can see that I've got a times 2 here and I've got a times 2 on the other side, so I'm going to cancel those out. So if I can do less work, fantastic. So what I did up the front here was actually we times through by that 2. I go, yeah, stuff that, don't have to do that now. And that's one of the joys, I think, of maths, is when you're doing stuff, you can do it again and do it a slightly different way and keep improving. Sorry about that. So now, on the left-hand side, I've got 2x take 5, and I want to get rid of this divide by root 2. So I'm now going to times the other side by root 2. So I end up with 2x take 5 equals root 2x. Oh. Root 2x. Root 2 times 3 is 3 root 2. Who thinks they'd be able to confidently solve for x at this point? Right, not many of us. However, if I said, could you solve this? Let's go 2x take 5. Actually, can I make that 12x? 12x take 5 equals 8x plus 15. What would you do? Yeah. You get your x's on one side. So to get rid of this plus 8, you would take 8x. Do you agree? And to get rid of this take 5, you would plus 5. So you end up with 20. Well, I'm going to do exactly the same thing here. It's just a little bit uglier. So it's now going to be 2x take root 2x. And it's going to be 3 root 2 plus 5. I like to write that as 5 plus 3 root 2. And some of you are still going, yeah, well, good on you, but that didn't help. Again, I ask you to go back and look at this. Now, all of you automatically will go 12x take 8x is 4x. What you don't know is you've done a bit of common factoring going out there. So you've actually gone, I'm keeping the x, I'm ignoring the x. 12 take 8 is in fact 4. So that's what I'm going to ask you to do over here. I'm going to keep that x out the front, and it's 2 take root 2 equals 5 plus 3 root 2. And now, how do I get rid of a times? Divide. And you go, God, this is just hideous. And this is when your calculators that you think, what a ripoff, $260. We kiss them. We go, we love you, calculator. You rock my world. Oops. Because, come over here. I'm not expecting you to write all this down, so I'm not waiting for people. We go fraction. I've forgotten what I wrote. 5 plus 3 root 2. 5 plus 3 root 2 over 2 take root 2. And that, my people, is the answer. If you look in your answers, they will say 8 plus 11 over 2 root 2. Can you see how they got that? 16 divided by 2 is the 8, and 11 over 2 is the... And that is what we mean by put it in that form. Where'd it go? Oh, geez, I did it again. I've moved my recording. Anyway, this A and B, basically put it as this Q, right? Put it as an integer or a fraction. No decimals. B could not be a square root. That's all that Q is saying. Is that okay? Hard question. But you're going to get one or two where it pushes the boundaries a little bit. And what I would be happy with is if you got to at least that first line. I'd be thrilled. If you left it blank, not so thrilled. Okay? All right. Time for you to just carry on doing your thing. I'm going to stop the video.